Hi guys, good evening to all of you. Yeah, let us start our session. Yes, guys, do you hear me? Hello.
Sir.
Good. Yeah, let us start our session. So previous class, structure of C program, top to bottom, like steps in writing is document. Yes, order of writing C program. Document part include files, define part, global declarations, main function, variable declaration, all this. Yes. So these are order of writing. This is we discussed already. So next about variables discussed, about variable discussed. What is variable? Next naming conditions of variable. So these were discussed. Right, okay. So next about data type we should discuss. About data type. Yes, about data type. Data type. About data type. Yes, in C language, there are 4 types of data types. So 4 types. Okay, there are 4 types. 4 types of data types here. First one, system defines data types. System defined data types. Next, second one, user defined. Yes, user defines data types. Yes, system defined data types, user defined data types. Yes, next, derived data type. Yes, next, empty data type. Empty data type. So these are 4 types. System defined data types, user defined data types, derived data type, and empty data type. First, let us say what system defines data type. System defined data type. So what are the system defined data types? Let us say about system defined data types. Okay. Yes, what is system defined data type? System defined means here system means what? System means compiler. Yes, here system means it's a compiler. System means it's a compiler. Okay, system means it's a compiler. So system defined types. That means it's a part of compiler. So these are from compiler. Yes, these are part of compiler. These are from the compiler. Compiler provides this. These are provided by the compiler. Compiler provides all these data types. System defined data types. Okay. System means compiler. Yes, here system defined. Not only here, you take any software like C language or Java or C++, Python, anywhere system defined type is there. System defined means compiler, like C compiler, Java compiler, Python compiler, different compilers are there. Yes, all the compilers are having its own type here. All compilers are having its own type. Those are called system defined data type here. Okay. So these are system defined data types, means compiler. These are from the compiler. So provided by the compiler, right? Yes, next others user defined by user here. User defined, derived, and empty. This topic later we'll discuss. Okay. At this stage, just system defined. Okay. Yes, you can understand only this system defined. If this is may not be understanding, these are part of structures. Later we'll discuss. Okay, in structures later getting here. You can't understand at this stage here. So first let us say about system defined data type here. System defined system is compiler. These are from the compiler. So these are from the compiler. So these are provided by the compiler, right? Yes, in the system defined type here. Yes, system defined type. There is a character type and numeric type. Character type and numeric type. 1 second. Yes, let me open some documents so that easy to understand. Yes, system defined Yes, system defines data types. System defines data types. Okay, system defined data types means yes. So for system defined data types, system defined data types. Yes, system defined data types. Yes, these are character type and numeric type. Again, two types here: character type and numeric type. Yes, character. Yes, character type and numeric type. Character type. Next, numeric type here. Character and numeric type. Character and numeric type. Character and numeric type. Right? Yes, character type. Next, numeric type. Right? So in this character type, this is for the characters, this is for the numbers purpose, and characters here. So character type, yeah, this is char is a keyword for this. Yes, char is a keyword for this character type. Char is a keyword. So this is char, right? Character type. This is to handle the characters, right? Okay. Yes, numeric type. Yes, in numeric type again two types here. Again two types like integer type and floating point type. Yes, yes, integer type. Next floating point type. Integer type. Yes, next floating point type. Yes, floating point type. Integer type and floating point type. Right? Yes, integer type. Next floating point type. Two types here. Integer and floating point type. Right? Yes, system defined like this. System defined type. Character type for the purpose of reading characters. Numeric type for the purpose of numbers. This is for the numbers here. Yes, char is the keyword for this. Yes, character type. Yes, integer type, floating point type. Yes, integer type. Again, we have different types here. Yes, integer type. Again, different types like yes, like short int. First one, short int. Short int. Yes, short int. Yes, short int. Next, int. Yes, int. Short int. Next, long int. Yes, next one is long int. Yes, in this integer type here. First one, short int. Short int. Next is int. Next is long int type here. Yes, long int. Yes, int is short int. Next long int. Again, three types like this. Okay, right? Yes, integer type, short int, next int, next long int. Three types like this. So why these three we'll discuss next. I'll tell you next. Why these three types again integer type for the integer numbers. Integer numbers like rounded number like 10, 100, 1000, maybe 10,000, something like this. Integer, rounded number. Next, floating point type. Yes, here also same three types here. Float, double. Yes, float. Next, double and long double. Again, three types here. Okay, float. First one is float. Okay, float. Float. Next, second one, double. 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 Next one is long double. Next is long double. Long double. Long double, right? So there are three types again like this. Yes, float. Next double. And next long double. So these are system defined data types. I think now it's very clear picture, right? System defined types here. First character type. Next numeric type is character type. Char is the keyword for this. Next numeric type, integer type, floating point type. Integer type in the short int, next int, long int. Okay, floating point type, float, double, long int here, long double here, like this. Okay, 1 second. Yes, let me take the copy of this one here. Yes, screenshot. Yes, I'll put in the document the screenshot. Yes, snipping tool.
Yeah, snipping tool.
Yes, copy. Yes, in this document, let me place here. Data types, 4 types here. System defined data types. Yes, so this is easy to understand. Yes, save this. Yes, I'm sending same document for you. Right? Yeah. So this is system defined data type. System defined character type, numeric type, character, char, integer. Yes, floating point. Next integer, short int, long int, float, double, long double is like this. Right? See, I'm repeating 1 second. This is snipping tool. Yep, this is the everyone must have this knowledge to prepare documents here. Yes, I'm repeating. See here, search in search. Here is snipping tool. Yes, search for snipping tool here. Search for that. Yes, yes, snipping tool. Select this. Click on that. Yes, open that. New. Here's a new default new here. New. Select new here. Now, yes, see this new. Yes, now you can see that mouse pointer changes like this. After changing whatever the area you want, you can select it here. Complete area you can select like this. Select like this and leave the mouse. Now leave the mouse. Right? Done. Leaving mouse. Okay. Now see here snipping tool. Yes, snipping tool. This is mouse, right? Now yes, place the mouse here. Hold on mouse. Just press mouse. I'm pressing mouse here. Press mouse. After pressing here, select the area, whatever the area you want. After selecting here, yes, like this. Now leave your finger here. Just leave the mouse. Right, done. Right, okay. So next after that, copy. This is here. You can copy. Here you can copy. Yes, after copying, paste into your document here. Paste into document here. Anywhere. Suppose here I want to just Control V. Paste. That's it here. Just you can paste in the document. Control V. So snipping this is yes. Control V. Paste in document, right? Yes. Just Control V. Paste it here. So anywhere you can paste it. Okay. Anywhere you can paste here. Paste in the document. Paste in document like this. Okay. Sometimes, suppose if you want whole screen, this only particular area, right? Yes, I want complete screen. Yes, how to take the complete screen? Any idea? Yes, guys. Suppose screen. This I want to take the complete screenshots. Okay. So how to take this complete screenshot here? For this, yes, print screen is there. Print screen option. Yes, shift key, shift print screen. Yes, 1 second. Let me close this. No. Yes, shift print screen. You can use like this. One second. Control. Yes, whole thing actually all print screen option is there. It's not working actually. Control print screen or shift to print screen. No, it's not working. Yes, only splitting tool is working. Yeah. Okay. Yeah, the print screen option actually it has to work. Okay, tomorrow I'll tell you. Okay. Yes. Now here. So about
Sir,
system definition, let us see this. Yes, always just checking Google. Can see this. Yes, system defined
hello.
type here. Yes. Yes. What is your doubt?
Sir, do we need to install that snipping tool?
No, it's not required. It's a part of OS. It's a part of OS. Not required to install. It's a part of OS. Okay. Yes, search option you can see that. Okay. Yes. Now these are different data system, different types like this. So this is for character type. Yes. Next, in numeric, integer, and floating point type here. Integer type. Yes. Short int, long int, floats, double, and long double like this. Right. Okay. Yes, in this here we have one more type like the signed type and unsigned type here. Signed data type and unsigned data type. Yes, what is this? Let us see here. Signed and unsigned. Okay, signed, signed and unsigned. Signed and unsigned data type here. Yes. So what is signed? What is unsigned here? Signed means with sign here either plus or minus. Signed means with sign here either plus or minus. Unsigned means no sign. First, let us say about sign here. So, what is sign type here? Signed. Yes. Sign type. Sign type. Yes, is a default type. Default is signed here. Default is signed. Yes, suppose I want to declare sign integer. Yes, signed int keyword like this. Signed. Declaration is like this. Signed int. Signed int suppose some variable A. Signed int here some x. Variable x, right? Okay. Yes. Here signed keyword is optional, not required because default is sign type. Yes, is a default signed. Yes, it is a default. It is a default. So it's a default type. So this is default type. Is a default type. So signed keyword is optional, not required. Without signed keywords. With or sign, with or without. Both are same here. Either this or that, both are signed here. Sign int, yes, int. So simply int x, both are signed because default type is signed. Signed keyword is optional. Signed keyword is optional here. Suppose if you want to declare unsigned type, you have to use unsigned keywords. Yes, we'll see next. So first, let us see what is signed type. What's the difference between signed and unsigned here? Just 1 second. Suppose if you want to declare unsigned type here, yes, unsigned. Yes, unsigned type. Unsigned type. Yes, unsigned type. Unsigned keyword int x. This is declaring unsigned here. Suppose if I remove this unsigned keyword, what is this? It's a signed type. It's a signed. See, unsigned integer. So this unsigned integer. If I remove this unsigned keyword here, then that becomes like a unsigned signed here. Default is signed. Yes, if it is signed, that signed keyword is not required. Reason, it's a default. Okay, signed type here. Yes, in signed type, yes, it's a default type. Signed type is a default. It's a default. It's a default here. Sign int x. Declaration like this, or simply int x. Signed keyword is optional. It's not necessary. Okay, right? Yes, unsigned type. Yes, unsigned type. Yes, in case of unsigned type here, yes, this is here declaration like this. Yes, if you declare like this, it's a signed here. Now this is unsigned type. Yes, we should use unsigned keywords. For unsigned type, we should use unsigned keywords. Yes, where to use signed, where to use unsigned, we'll discuss. Just wait here. Yes, here sign type. Yes, is a default type. So this is without. Yes, sir, with sign. With sign here. With sign. Yes, either plus or minus, either plus or minus, either plus or minus here. Okay, sign either plus or minus. Okay, right? Yes, unsigned type. Unsigned type means no sign here. So this is no sign. Yes, no sign here. No sign. Okay, just it is a it is a rounded number. Just rounded number here. Just it's rounded number. Yes, no sign for, yes, no sign for this. Okay, no sign. Yes, here there's no sign. Even there's no plus, no sign, no plus here. Just it's a rounded number. Just it's a rounded number. That's it here. Just it's a rounded number. Okay, right? Yes, exactly what is sign type and sign type. Yes, let us see. See, 1 byte. 1 byte equal to how many bits? 1 byte equal to how many bits?
1024.
8 bits.
1 byte equal to how many bits?
8
8
bits.
bits, 8 bits. Sorry.
8 bits. 8 bits. 1 byte equal to 8 bits. Okay. 1 byte equal to 8 bits. 1 byte equal to 8 bits, right? Here this is data. Yes, volume like this. 1 byte. Next 1 KB. Next 1 MB. Like this. 1 GB like this. Yes, after bytes here next KB. 1 KB. 1 KB equal to how many bytes? This is minimum knowledge in software field. You must get this basic knowledge. Of course, I am not expecting you from you here because you are a beginner. C language means it just is the beginning. So I'm not expecting anything from you here. Suppose if you have the knowledge, just you can answer my question. 1 byte equal to 8 bits here. Next 1 KB equal to how many bytes? 1 KB equal to how many bytes? If you have this,
1024.
answer me. I'm not
1024 bytes.
Yes, 1024 bytes, right? Get 1024 bytes. Okay. Yes, if you have the knowledge, and then well and good. So don't have this. I'm explaining here. Try to remember this. Okay. So kilo means 1024. Kilo means 1024 here. So 1 KB equal to 1024 bytes. Yes, after KB, what is next one? After KB, next what?
MB.
MB, megabytes. So next is megabytes. 1 megabyte is equal to, yes, 1024 kilobytes. Okay. Yes, guys, here I am expecting answers from others also. Please try to respond. Yes, not only one or two here, all of the members. Yes, if you know the answer, just you try to try to explain that answer here. Don't keep quiet. Yes, in software field, you must talk more. Who is active in talking, they will be success in software fields. Yes, you have to talk more in software fields. Okay. So 1 byte equal to 8 bits here, 1 KB equal to 1024 bytes here, 1 MB equal to 1024 KB. Yes, after MB, what is next one?
GB.
GB.
Yes, next is GB, right? So 1 GB. 1 GB. Yes, of course, I'm not expecting. Okay. Yes, no, because you are a beginner, I'm not expecting this one here. So 1 GB equal to, yes, 1024 MB. Yes, after GB, next is a
Terabyte.
Terabytes. 1 terabyte equal to 1024 GB, right? Yes, after terabytes. Next what?
Gigabyte.
Gigabyte.
Petabytes.
Okay.
1 petabyte equal to 1024 terabytes. Okay, so terabytes, petabytes. After petabyte, what is next?
Giga.
Gigabyte.
No, no.
Gigabyte.
Like
Gigabyte. EB.
1 exabyte is equal to 1024 petabytes. Okay, so 1 exabyte. After exabyte, next what?
ZB.
Now zettabytes. Zettabytes equal to 1024 exabyte, right? Okay. See here, same thing is there in document here. Yes, I have prepared in document also. Yes, all these points, whatever discussing here, everything is there in document. Okay. Yes, 1 byte equal 8 bits. KB 10 to the power of 3. This is 10 to the power of 3 here. So this is 10 to the power of 3. 10 to the power of 3. Yes, next. This is MB means 10 to the power of 6, right? Yes, MB. It's 10 to the power of 6. MB 10 to the power of 6. This is after 10 to the power of 6. Next 10 to the power of gigabytes is 10 to the power of 9. 10 to the power of 9, right? Yes, next. Yes, after 10 to the power of next 10 to the power of 12 here. Terabytes 10 to the power of 12 here. Next is 10 to the power of 15. Yes, next this is 10 to the power of, yes, 10 to the power of 18. Yes, after this next is 10 to the power of, yes, 10 to the power of, yes, 21 like this. Oh, 21. Okay, right? Yes, kilobytes, yes, megabytes, gigabytes, terabytes, petabytes, exabyte, and zettabytes. So kilobyte 10 to the power of 3, 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, 15, yes, 18, and 21 like this. So this is software data volume. Yes, data volume measuring units here. Data volume. How much? Yes, how much data? Yes, data volume. Yes, what's the volume of your disk here? Maybe asking this kind of questions here. What's the volume of your disk? Maybe 1 terabyte, right? Yes, in your system. What is your disk capacity? That is called as volume. How much volume? Yes, 1 terabyte, 1 TB disk, maybe 500 GB like this. Okay, suppose movie. What is size of movie? How much volume of your movie here? That is called a volume. It's a volume, size in volume. Data always size in volume. Okay, volume. Yes, how much volume of your, yes, movie? Suppose my 3 GB movie, 2 GB movie like this. That is called as volume. Yes, how much volume? Free space and user space. Okay. Yes, you can check this, right click properties. From that you can check this volume of face. This is called the volume here. So data measuring units like this. Okay, now let us come to actual topic here. So 1 byte equal 8 bits. Okay, fine. See, up to GB just is small data. Up to GB is a small data. Yes, from terabytes to zettabytes, this range called as big data range. Yes, terabytes to zettabytes, big data range. For this big data range, we can use Hadoop. Hadoop is a solution. Hadoop is a solution to handle the big data. Big data range, terabytes, zettabytes. For this range, yes, Hadoop is a solution for the big data. Right? Okay. Yes. Of course, not required for us. Now, let us come to actual topic here. 1 byte equal 8 bits. Let us take 8. Let me take 8 bits here. 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. 8 bits. Yes, 8 bits. For example, so 8 bits. 8 bits. Yes, 1 byte equal 8 bits. This is 8 bits. So this is called first bit. This is second bit. This is third bit. This is fourth bit, fifth bit, sixth bit, seventh bit, and eighth bit. Right to left. Right to left. So this is first bit. This is called first bit. This is called last bit here. So this is last bit. So this is last bit. Okay, last bit. Next first bit. Last bit and first bit. Last bit and first bit. Okay. Yes. So this is last bit here. 1 second. Yes, this is last bit. Okay, so this is last bit here. Next, this is first bit here. Last bit. Next, this is first bit here. Right? Okay. So this is called as first bit here. So this is first bit and last bit like this. This data here. So this is first bit. So this is first bit. This is last bit. So first bit and last bit, right? Okay. Yes, here last bit always sign here in sign type. Yes, in sign type here last bit is always sign here. Yes, last bit always sign here. So last bit contains sign here. Yes, in sign type, yes, last bit contains sign here. Sign. Yes, last bit always sign here. Yes, plus. Yes, see here 0. Last bit value 0. It's a positive value. If it is 0, it's a positive value. Yes, 1. Suppose if it is 1, then it's a negative value here. So negative value. So 1 positive value. Yes, 0 positive value. 1 is negative value here. Suppose here 0. If it is 0, it's a positive value, right? Yes, here it's a 0 means positive value. 1 means negative value, right? Okay. Suppose for example here, yes, binary code of 10. Binary code for 10. Yes, what is binary code for 10 here? It's a 1010 binary code. Yes, previous class we discussed 1010 is the binary code. Yes, binary operation dividing with 2 here. 10 dividing with 2 binary operation. Yes, we try binary operation to get the 1010. Previous class we discussed here 1010. So it's a 10. It's a positive integer, right? Positive value here, right? Okay. So 10. So in this way, yes, 10 1010. So for this right to left. So this is 0 here. Next here 1 filling here. Next here is a 0. Sorry, here is a yes. Sorry, 1. This is next. This is 0. This is 1. Next remaining empty bits are zeros. Next this is 1. That's it here. Sorry, this is 0 because it's a positive value. Yes, 10 binary code for 10 is 1010. Binary code for 10 is 1010 here. Yes, it's a positive number, right? It's a plus. So plus means 0 here. Yes, last bit, the last bit. Okay. So 0 means positive value, 1 means negative value here. So this is first bit, 0 here, 0 1 0 1 like this, right? Okay. Now this 1010. Okay. Now this is, yes, again you can convert into 10 here. So how to convert into 10 here? See this position in this. See this position. Yes, this position is 2 to the power of 0. This position is 2 to the power of 0 here. This position is 2 to the power of 0 here. 2 to the power of 0. Yes, 1 second. Yes, that position. Yes, 2 to the power of, this is 2 to the power of 0 here. So next position. See positions like this. So next position. Next position. Yes, next position. Yes, next position. See here, this is a first equation. Okay, 2 to the power of, this is, so next equation. So next equation. So next equation. Yes, next equation. Next equation or next equation like this. See here, this equation is a 2 to the power of 0. So next this equation is what, 2 to the power of 1. Here this equation is 2 to the power of 2. This equation is 2 to the power of 2 here. This is 2 to the power of 3. 2 to the power of 3 here. This equation is 2 to the power of 4. This equation is 2 to the power of 5. Yet this equation is 2 to the power of, yes, 6. This is 2 to the power of 7 like this. So now this case, what is this value here? See here 2 to the power of 0. So first 2 to the power of 0, right? Yes, 1 0 1 0 1 0 1 0 bind the code, right? Now this is converting numeric format. Converting numeric format. So 0, this 0 into 2 to the power of 0, right? So 0, yes, 0, yes, into 2 to the power of 0. 0 into 2 to the power of 0, right? So this is okay, right? Plus next. So here it's a 1, right? 1 into 2 to the power of 1 here next. Plus 1, yes, into 2 to the power of 1, right? Next 0 into 2 to the power of 2 here. 0 into 2 to the power of 2 here. Yes, 0, yes, into 2 to the power of 2 here. Plus, okay, right? Yes, next. After this here it's a 1, right? 1 into 2 to the power of 3 here. So 1, yes, into, yes, 2 to the power of 2 like this. So what is this value here? Say this. So what is this value here? What is this value here? 2 to the power 0 into 2 to the power of 0. It's a 0, right? So this value is 0, right? So this is 0. This is 0 plus, yes,
Sir, 2
next.
cube, sir.
Yeah, 2 to the power of 3. 2 to the power of 3. Yes, next equation. This is 2, right? Next equation. Yes, this is 0. Next equation 8, right? So 8, next equation 8. So 8 plus, yes, 0 plus, okay, 0 plus 2 plus 0, right? See that value here. So this equation is 2 to the power of 3, it's 8 here. 2 to the power of 2, it's a 4 into 0, 0 here. 2 to the power of 1, 2, right? 2 plus 0, 2 plus 0. So what is this value? This value is equal to how much? It's a 10, right? Yes, this is. So this is converting binary to integers like this. Right to left always here. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of like this. Right? This is sign type here. Sign type. Sign type, right? Yes. If it is unsigned, yes, in unsigned here, in unsigned, last bit is also for data, is also for data here, is also for data. Yes, unsigned type. Yes, in unsigned type, last bit is also for data here. Unsigned type, last bit is also for data. Right? Okay. Yes. Suppose, for example, here, let us take one more example. Yes, one more example. This is sign type. Yes, sign type. One more example. Sign type. See, sign type. Suppose if all bits are, yes, all bits are ones. What happens here? All bits are ones here. Suppose this is 1, right? Next this is 1. Next this is 1. Next this is 1. This is also 1. All are ones. But this is 0 because of sign. Is a sign, right? Okay. Sign type. Yes, all bits. Yes, in sign type here, last bit is always reserved for sign here. Remaining 7 bits for data here. Signed and unsigned here. Signed, unsigned. In sign type here, last bit is always for sign here. Remaining all the bits for data. Now what's the value? All bits are ones. In sign type here, all bits are ones. So this is for data, right? This is not data here. This is not data. In sign type, this is not data. So this is for the sign here. Yes, all bits are ones. Then what's the value of this? All bits. If all bits are ones, then what's the value of this? Let us see that. Let us check it here. All bits are ones. If all bits are ones here, so this is 1 into, right? Yes, plus. So 1 into 2 to the power of 6. Yes, 1 second. Plus, yes, 1 into 2 to the power of 6, right? Plus, yes, plus, yes, 1 into 2 to the power of 5, right? 1 into 2 to the power of 5, right? Yes, next. Plus, yes. So next plus, so plus, 1 second. Yes, plus, next here plus, here plus, here plus, next here plus. So what is this value here? So this is 1 into 2, yes, 1 into
255.
this is 1 into, yes, 1 into, yes, all are ones, 1 into, right, all are ones. So what's the value of this? Let us see this. So 1 into like this, like this. So 1 into this is. So what's the value of this? So first, what is this value here? This value is 2 to the power 0, it's a 1, right? So 1 into 1, it's a 1, right? So this position is 1, right? So this position is 1. So what is next? This position is 2, right? Yes, this position is 4. Next, this position is 8. Yes, 1, 2, 4, 8. Next 16. Okay, 16. Next question is 32. Next question is, yes, 64, right? Yes, this value here. See this 64. So this is 64. This is 32. This is 16. So this is 8. Yes, 1 second. One more. Yes. So this is 4. Yes, 2 to the power of 0, 1, 2, 3, 4. Yes, 5, 6, and 7. Yes, 7. Yes, seventh bit is a sign, right? No, we don't have this one here. Let me remove this one here. So up to this is the 64, 32, 16, 8, 4. Yes, next. So this is 2. Yes, this is 1, right? So what is this value here? So 60, this total value is equal to, yes, it's a 127. This value is equal to 127. This value is equal to 127. So this is 127, right? Okay. So this value, total value, yes, the sign type, yes, if all bits are ones, then result is like this. Okay, all bits are ones. Yes, data part is all are ones, right? This is sign 0, right? 0 means positive value here. So plus 127. Okay, all bits are ones, then it's a 127, right? So this is sign type here. Sign type. Yes, same thing. Let us take for unsigned type here. Yes, if it is unsigned, what is this value here? Same thing for unsigned. Yes, if it is unsigned. Yes, if it is unsigned here. Yes, unsigned. Yes, last bit unsigned type. Last bit also for data. Last bit also for data here. Last bit also for data. Yes, in unsigned type, last bit also for data. That means in place of 0, it's a 1, right? Suppose this is 1. All bits are ones. Okay. Yes, if all bits are ones. Okay. Last bit is also for data here. Okay. If, yes, all bits are ones. All bits are ones. So what is this value here? Now this is 2 to the power of 7. Now we should add this also, right? So this is plus, yes, 2 to the power of 7 plus 2 to the power of 7, right? We should add this also. So plus 2 to the power of 7 plus 2 to the power of 7, right? So what is this value? Say 128, right? Now 128. So this is 128, right? So 128 plus 64 plus 32 plus 16, 8, 4, 2, 1. So what is this value? This value is equal to, it's a 255.
255.
255, right? So 128 plus, yes, 128 plus, yes, 127. It's a 255, right? This is, I think clear, right? Okay. Yes. See, in signed, this signed type, this signed, yes, so signed 1 byte value, signed 1 byte, 1 byte max value is equal to how much? It's say 127. Next, unsigned, if it is unsigned, yes, 1 byte max value, yes, 1 second, 1 byte max value is equal to, it's a 255, right? So this is signed, unsigned here, right? So signed 1 byte maximal is 127 here. Yes, unsigned, yes, if it is unsigned, last bit is also for data. If it is unsigned, last bit also for data. Here unsigned 1 byte maximal is 255. That's the difference, right? Okay. So this is, yes, 1 minute. See, this is for, yes, one byte. Yes, let us take 2 bytes here. Suppose if it is 2 bytes, how it's working? Let us take 2 bytes here. 2 bytes. 2 bytes of data. Now you can understand very clearly. Yes, one more example, 2 bytes. So 2 bytes of data. 2 bytes. Let us take 2 bytes here. 2 bytes. Yes, signed. Yes, 2 bytes sign type here. Yes, here I'm adding one more. Yes, 2 bytes. This is 2 bytes, right? 2 bytes. Okay, 2 bytes. Yes, 2 bytes here. In this, yes, 1 second. So this is first bit. In 2 bytes of location, this is first bit. Okay, so this is first bit. This is first bit. Next, this is last bit. Here, this is last bit. This is first bit. This is last bit. Right? Okay. So first bit, last bit. Right? Okay. So first bit. 1 second. So this is, yeah, this is first bit. This is last bit. Last bit is for the sign. It's a sign, right? Sign type. Last bit. Yes, either plus or minus, right? It's a sign here. Sign. Last bit. Yes, plus means 0, minus means 1, right? So last bit, it's a sign. Last bit is for the sign here. First bit, this first bit, right? First bit, last bit is like this. Okay, I think clear, right? Okay. Yes, the sign type is like this. So first bit and last bit is like this. Okay, right? Yes, in this case, all bits are ones. How this is working? Let us see. This is one. Next, this is one. This is one. This is one. Yeah, this is one. This is one. This is one. This is one. Next one here. There's one here. One here. All are ones. All are ones. All are ones. So this is 0 because sign type. All are ones. So what's the maximum value here? This case. So same here. 2 to the power of 0 to. Yes. Now this is. Yes. Not 2 to the power of 0. 2 to the power of 1, 2, 3, 4, 5, 6, 7. This is what? 8 bit. 2 to the power of 8 here. 90 bit. 2 to the power of 8 here. This is 2 to the power of 9 here. So this is 2 to the power of 10. So this is 2 to the power of 11. Yes. Next, this is 2 to the power of 12 here. 2 to the power of 12. Yes. This position is 2 to the power of, yes, 13. This position is 2 to the power of 14, right? 2 to the power of 14, right? Yes. Yes. Next, this position is 2 to the power of 15. Okay, 2 to the power of 15 here. This position is 2 to the power of 15. Right? Okay. So this question is 2 to the power of 15, right? This is like this. So you get 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like this. Okay. Suppose if all bits are ones here. Here this position value 0 means a sign, right? This is for sign here. Sign. Then what is this value here? So what is this value here? This value. Yes. So this value plus, so 64. Yes. So what is this for 64? After 64, what is next one here? Next value after 64 is a 128, right? 64, 128. See here, I'm repeating. See, first question. What is the first question? It's a 1, right? Second question, it's a 2. Next question 4. Next question 8. Next question 16, right? Next question 32. Next question 64. Next question 128. Next question 256. So next question, yes, 512. Yes, next question, yes, 1024, right? Yes, next question 2048. Yes, next question, yes, 4096. Next equation, yes, 8000. Yes, 182, I think. Yes, 4 plus 4, 8, 96 plus 96, 180, 192. 192 here, 192. So next equation value. See, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Yes, 2 to the power of 3, 4, 5, 6, 7, 8, 9, 12, 13. Yes, 14. Yes, after 14. Yes, next 15. Yes, no, up to this much only here. This is, yes, this is 2 to the power of
Sir,
0,
counting mistake, sir.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 128. 1 second. Let me check 1 second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, next 13 plus 13. So 8,000. Yes, 192. 8,192 plus. So 4,096. W is 8,000 plus 96, 96. 180 plus, yes, 192. Next. Yes, next double of this is 16,000. Yes, 192. Yes, 384. 200 plus 90 plus 183. Yes, 8. Yes, 16,384. 384. Yeah, this value, this total value is equal to, this total value is equal to 32,765. This total value is equal to 32,767. Yes, signed type. Yes, 2 bytes max value. Yes, signed. Yes, signed. Yes, in signed type 2 bytes. Yes, you must have this knowledge, minimum knowledge in software field here. Signed 2 bytes, signed 2 bytes, max value, signed 2 bytes, max value equal to 32,000. Yes, 767, 767. Signed 2 bytes, max value 32,767. Right? So this is signed type. Right? Okay. Yes, same thing. Yes, same 2 bytes, same 2 bytes for the unsigned. If it is unsigned, then what's the maximum? Let us see this. So this is signed here. Let us take for unsigned here. Unsigned type. Yes, if it is unsigned, let us see unsigned type here. Unsigned. Yes, unsigned type. Yes, in unsigned type. Yes, last bit. Yes, last bit is also for data, right? Last bit is also for data. Last bit is also for data, right? Suppose all bits are 1. Suppose this is 1. 1 means out of this it's a data. This is previously signed type. In signed type, suppose this is means is negative value. Suppose if it is 1, this value becomes minus. This is, that is negative value here, minus. Okay, right? Yes, 0 means is a positive value. Now this case unsigned type, last bit is also for data. Last bit is also for data. So this is 1, right? So if it is 1, so for this, what's the value here? This value. So next equation, next value is plus. So double of this is, yes, 32,768. 768. Okay. So up to this, see this value from this to this, it's a 32,767 plus 32,768. So this value is equal to 65,000. Yes, unsigned. Yes, unsigned 2 bytes maximum value is equal to 65,535. That's it here. Okay. Now let us come to conclusion here. Yes, the signed 1 byte, signed 1 byte, max value. Yes, max value is equal to, yes, 127 here. The signed 1 byte, max value is equal to 127 here. Yes, next same thing unsigned. Yes, if it is unsigned here, same thing. If it is unsigned 1 byte max value. Yes, unsigned. Yes, unsigned. Yes, unsigned 1 byte maximal is equal to 250 farad. It's a 255. 250 farad. Yes, the same thing if it is 2 bytes. Yes, if it is 2 bytes. Yes, the signed 2 bytes max value is equal to, this value is 32,767. Yes, next unsigned 2 bytes maximal is 35,535. 35,535. This is right. This is, so this is data. So range of data is like
Sir,
1
65,000.
byte. Yes, 1 byte max value. Yes, 2 bytes max value. Signed 1 byte max value 127. Unsigned 1 byte max value is 255 here. Signed 2 bytes max value 32,767. Unsigned 2 bytes max value 35,535. Fine. Right. Okay. Signed and unsigned. What's the difference between the signed and unsigned?
65, sir.
32,767.
That is unsigned
Unsigned
65,535.
65,000. 65,535. 65,535. Okay, fine. Yes, signed, unsigned difference is this. Now, what's the difference between signed type and unsigned type here? Yes, in sign type, last bit is always for the sign, either plus or minus. 0 for the plus, 1 is for yes negative value. Okay, right? Yes, next when come to unsigned type here. Yes, unsigned type last bit is also for data. Last bit is also for data. That is difference between signed and unsigned here. Sign type and unsigned type. Yes, in sign type here, last bit is for the sign and rest of the bits for data here. Next, unsigned type. If it is unsigned type, yes, last bit is also for data, including all last bits. Suppose 1 byte of memory, 1 byte of memory here. First 7 bits for data, last 8 bits for the sign here. So 2 bytes of data. 2 bytes of data. In this case, first 15 bits for data. First 15 bits for data, last bit 16th bit for sign. Right again. Suppose 4 bytes of memory. If it is 4 bytes of memory, 4 bytes equal to how many bits? 4 bytes equal to how many bits? 1 byte equal to 8 bit. 1 byte equal to 8 bit. 4 bytes means how many bits?
32 bits.
32 bit, right? Yes, in 32 bit. In 32 bit here, first 31 bits. Okay. Yes. See, this is like suppose if it is 4 bytes, then 4 bytes of memory. Yes, you can see 4 bytes of memory like this. So this is 4 bytes. This is 4 bytes. First 8 bits, next 8 bits, next 8 bits, next 8 bits. This is first bit. This is last bit here. Clear? Okay. So first bit and last bit is like this. Okay, right? Yes, here this is first bit, this is last bit, this is last bit here, here is last bit here, this is last bit, so this is last one, so this is last bit, this is first bit here. Yes, I think you understand, right? The first bit and last bit like this. So here, yes, all this, yes, up to this, yes, here up to this 31 bits, 31 bits, these 31 bits are yes data, last bit 32 bit is a sign here. Yes, if it is unsigned type, all bits for data here, all bits for data, unsigned all 32 bits for data here. Okay, yes, sign type last bit is for the sign here, only 31 bits, right? Okay, suppose 8 bytes of memory, same 8 bytes means 64 bit, right? It's a 64 bit memory space. Yes, 64 bit memory space. Yes, that case 64 bit, 64 bit, right? Yes, like this 64, 1 2 3 4 5 6 7 8 bits, 8 bits, right? So first bit, yes, next this is last bit, that's it here. Okay, so 1 byte or 2 bytes, 4 bytes, 8 bytes, sometimes 16 bytes, something like this. So first bit and last bit is like this. I think you understand, right? Okay, so here in sign type, suppose if it is sign type here, so this is either plus or minus, right? Okay, yes, if it is unsigned here, yes, this is 1 or 0. Yes, 1 means data, it's not a sign here. 0 means data, it's not a sign here. That's the difference here, right? Okay, so here what's the difference between signed and unsigned here? Maybe 1 byte of memory, 2 bytes of memory, 4 bytes of memory, or yes, 16 bytes of memory, 8 bytes, anyone here, 1 byte, 2 byte, or 4 byte, 8 byte, any location here, any size, any size. In sign type, last bit is for the sign and rest of the bits for data. In unsigned type, all bits for data here. That's the difference between signed and unsigned. I think here everyone you understand, right? I hope everyone you understand signed type and unsigned type, right? Yes, lot of time taken for the explanation.
Yes,
Yes,
sir.
everyone you understand, right? Hello guys, I'm not getting response from you. You understanding or not?
Yes, sir.
Okay, fine. Yeah, just I'm explaining like just like a very spoon feeding. This is basics. So this knowledge, any software engineer must have this knowledge. C is the basic for, yes, if you're strong in C language, yes, other language very easy here. Okay, these are the fundamentals, you must have this knowledge here. So the difference between signed and unsigned here. Now come to these data types here. Yes, in these data types. Okay, Yes, which is signed, which is unsigned here. Let us see this. Characters. See here in this character type. Character type always it's a unsigned. There is no sign for the character. Character type always unsigned. Characters always unsigned here. There is no sign for the character, right? Suppose your keyboard characters. Yes, your keyboard characters. Suppose character A, right? For A, there is no plus, there is no minus, right? No plus, no minus, right? Plus A, no, don't have. Minus A, don't, just simply A, right? A, that's it here. So characters always unsigned. Not only C language, you take any software, C language or C++, Java, Python, take anywhere here. Characters always unsigned. Okay, characters always unsigned. Okay, fine. Characters always unsigned here. Yes, next. Characters always signed here. Next, floating point type. Yes, when come to floating point type here. Yes, in case of floating point type. Yes, floating point type always signed here. Floating point type. So these things, right? Floating point type. So this one, floating point type. Yes, these are floating point type. So this is always signed here. Floating point type always signed. Okay, so characters always unsigned here. Floating points always signed here. No unsigned. In floating point type, no unsigned. Right? Okay, characters always unsigned here. Yes, characters. Character is always unsigned. Character is always unsigned here. Yes, floating type point type is always signed here. Yes, when come to integer. Yes, in floating point of no unsigned concept, always signed here. Yes, when come to integer type here. Yes, in case of integer. Yes, integer type. They are integer types, right? Yes, integer types. These integer types is, these are either signed or unsigned here. These are either signed or unsigned. Okay, sometimes signed here or sometimes unsigned here. Signed, signed integer, unsigned integer. But in case of float double, always signed here. There is no unsigned float, unsigned double, unsigned long double like this. So these always signed type. Floating point is always signed type here. Integer type is either signed or unsigned. When come to characters, characters always unsigned here. I think you're right. Okay. Yes. Next. See what is size of the data types here. Yes, size of character is 1 byte. Yes, short int. Yes, size of short int. Yes, size of short int is, this is 1 byte. Size of short int is 1 byte here. 1 second. Size of short int 1 byte. Yes, next int 2 bytes. Yes, long into 4 bytes. Okay. Next float. Size of the float is 4 bytes. Next double is 8 bytes. Long double is 10 bytes. Okay, right? So the size of data types, right? Size of data types. Yes, everything prepared in document here. Yes, even I'll review the document also. Right, okay. Yes, size of the character is 1 byte. Size of the character is, yes, this is 1 byte. Size of character, this is 1 byte. This is 1 byte. Size of the character is 1 byte here. Short into 1 byte, into 2 bytes, long it is 4 bytes, float is 4 bytes, double is 8 bytes, long double is 10 bytes. Now doubt is here, why these three types, short int and long int here. Suppose here, for example here, yes, I want to store 10, just storing 10 here, declaring some variable, storing 10 for the purpose of storing 10 here. Suppose I'll declare some int a or long int a, for example here, long int a equal 10. Yes, what happens here? Long int a, long int. So what is size of long integer here? Size of long int. Let us see size of long int. What is size of long int here? Yes, size of long int
4 bytes.
4 bytes. Short int long. Short. See, is very easy to remember this here. First is short int, next int, next long. Short int and long, right? Okay. Short means small, next medium int and big number, right? Like this. Short int, long int. Short int 1, starting with 1 byte, next 2 bytes, 4 is double, right? Float 4 bytes, double 8 bytes, long double 10 bytes. Character is always 1 byte here. Okay, right? Yes, storing 10 for the purpose of storing here 10. Just I will declare For storing 10, I'll declare long int a, right? So what is size of a here? Size of depends on type, right? What is size of type? What is type long int? What is size of long int here? Long int. Yes, short int 1 byte. Yes, short int 1 byte into 2 bytes. Long int 4 bytes, right? 4 bytes of memory, right? 4 bytes. Yes, a equal 10. 10. What is binary code of 10 here? 1010, right? Only 4 bits. 4 bits means 1 byte is enough, right? 1 byte is enough. But we are declaring long int means 4 bytes. 1 byte is enough here. But we are declaring size with 4 bytes, right? What happens? 3 bytes of memory space wasted, right? Wasting of 3 bytes. Instead of wasting it, just declare as short int. Declare as a short int, right? Just is a short int. Declare like a short int. So when you declare like a short int here, what is size of this here? Only 1 byte, right? Only 1 byte without wasting memory space. Without wasting memory space, now we can utilize, right? Now utilizing memory space. Okay, utilizing. So effective utilization of memory space for this purpose, different types here. Right, okay. So a short int reason is this. Short int, long int reason is this. Okay. Yes, the short int 1 byte. So what is 1 byte max value? 127, right? Suppose your data more than 127, then go for integer, next one here. So integer 2 bytes. 2 bytes maximally 32,767. Yes, our data from 128 to see up to 127, you can go for short integer. Up to 127, short int you can declare here. Up to 127 our data. Suppose more than 127, suppose 128, from 128 to 32,767 declare integer 2 bytes, right? Suppose data more than 32,767, then go for long int. Long int. Okay. Yes, data your number is more than 32,767. That case go for long int. Suppose very big number, more than 6 digits. Your number is more than 6 digits, then go for string. More than 6 digits, then is a string here. Right, okay. Yes, similarly float, small number, real number like 10.6, maybe 20.5, suppose 100.50, something like this. So real numbers, for real numbers, number with decimal part, right? Like 10.5, 10.6, 20.6, 30.5, 30.3, something like this. That case, okay, float small. Suppose small number, go for float here. Medium range number, go for double here. Yes, big number, then go for long double here. Small number, yes, medium range number, next big value here. That case, go for long double like this. Right, okay. Right, next. Yes, when complete characters here, 1 byte, right? Character 1 byte. So 1 byte, characters 1 byte. Yes, about character, let us see here, character 1 byte. Yes, size of the character is, yes, size of a character. Size of a char, yes, 1 byte. So size of the char, it's a 1 byte, right? Yes, 1 byte. Yes, it's a unsigned. Yes, characters are unsigned, right? Char is a unsigned type. It's unsigned, right? Character is unsigned here. Yes, unsigned. Character is unsigned. Yes, unsigned 1 byte. What's the maximal here? 1 byte max value is equal to 255, right? 255. That means characters are 0 to 2. Yes, all are zeros means 0. Yes, all are zeros. Yes, that 1 byte, 8 bits, all zeros means 0, right? Maximal is all ones means maximally. That means 0 to 255, right? 0 to 255. Yes, characters are, yes, character value ranging from 0 to 255. Yes, this value, this range is called as ASCII range. It's a ASCII range. So what is ASCII here? ASCII stands for what? What is ASCII? ASCII stands for, yes, American
American Standard Code for
American Standard Code for, yes, information and interchange. Information and interchange. Right, okay. Information and interchange. American Standard Code for information and interchange here. So this is basic knowledge in software field here. Okay, 0 to 255. Yes, size of the character is 1 byte. Yes, 1 byte here. This is unsigned type. Characters are always unsigned. Unsigned 1 byte maximal is 255. Unsigned 1 byte. See, unsigned 1 byte max value is 255. So 2. So minimum value for 0 to 25. This range is called as ASCII range. This is called as ASCII range. ASCII range, right? Okay. ASCII range. Suppose, for example, here, for example, suppose alphabets. Suppose capital A to Z alphabet. Range of this is 65 to 90. Suppose small A to Z, lowercase A to Z. Lowercase means uppercase means capital letters, lowercase means small letters. Yes, lowercase A to Z is yes 97 to 122. Right? Okay. Yes, here maybe some doubt here. Yes, here these are the alphabets. Why? What is this number here? What is 65? What is 90 like this? Here A character cannot be stored into numbers here. Sorry, character cannot be stored in memory here. Yes, in memory. This is memory, right? This memory storage type is what? Binary format. Yes, in memory storage format, binary format. Yes, always in memory data storage in like a binary format, like a zeros ones, like a zeros ones. Okay, storage format is yes binary format, always binary format. Now A, see this A cannot be stored anywhere here, right? Okay, for this A, yes binary format. What's a binary format for this here? For binary format purpose, yes, for each and every key on the keyboard, so number is given. That number is called as ASCII value. For A, ASCII value 65. Okay. Yes, Z ASCII value 90, right? 65, 66, 67 like this. Okay. So these are ASCII values 0 to 255. They are called as ASCII range. So every key on the keyboard, for every key on the keyboard, there is a number. Okay. Suppose when you hit on A here, suppose when typing A, what happens here? When you hit on A, that generates 65. 65 converts into binary code. 65 converts into binary code. Okay. After converting to binary code, that binary code stores in memory. Yes. What is 65 binary code? Yes. 232 is remainder is 1. Yes. Next 16 0. Yes. Next 8 0 4 0. Next 2 times 0. Yes. Next 2 times 1 time is also 0. Next 0 times remainder is 1 here. So this is binary code for 65 here. Yes, 150 is 1, right? So this position is, what is this position here? This is 1, right? This is 1. This position is 1. All zeros. This position is 64. 64 plus 1 is a 65, right? I think everyone you understand, right? Yes, 150 is here. 150 is 1. So when you hit on A, here, for this number 65 generates. When hit on A, when you typing A here, keyboard driver generates 65. That 65 converts into binary format like this. That binary format storing to yes memory here. Storing to memory, right? Next, while reading from memory here, reverse. So first reading yes this binary code. That binary code converts in 65. That 65 converts into A, then displaying on screen here. Like this, vice versa like this. Okay. Right, this is so for this purpose, for binary conversion purpose, for each and every key some value is given. That value is called ASCII value. See, in memory storage format is binary format, right? Okay. Yes, to convert into binary format some integer number required. So for this purpose, for each and every key some number is given. Here. That number is called as ASCII value. Yes, keyboard ASCII values are ranging from 0 to 255. So this is ASCII range. I think clear, right? About character, right? Okay. So signed, unsigned, next size of data. Yes, all things like this. Okay. Let us go to document. Yes, let us review document here. See here, C language has 4 types of data types. Yes, today topic data type. Okay. Yes. What is data type? Storage type, right? It's a storage representation of a variable. Storage type. What's the type of data storing the variable? So first system defined data type, user defined, derived and empty here. System defined. Same thing, right? Yes, next. Yes, here system defined data types. These are provided by the compiler. These are also called as predefined or fundamental or basic type here. They are part of compiler. Yes, these are 2 categories: character type and numeric type. Yes, numeric character type is for the characters here. Numeric type integer floating point type. Yes, integer to store rounded numbers. Floating point to store real numbers. Storing real numbers. Character is always unsigned here. Yes, integer can be signed or unsigned here. Floating point type is always signed here. Same topic already we discussed here. Yes, integer type. In integer is signed and unsigned, right? Yes, signed short int. Yes, signed short int. Yes, signed int, signed long int. Yes, unsigned short int, unsigned long int, right? Default integer is signed type here. Yes, int a. Yes, treat as signed type. Reason signed keyword is optional here, not necessary here. Yes, default integer is signed type. So signed keyword is optional. So is not required. Floating point, float double long double here. Yes, characters always unsigned here. Float double long double always signed here. Yes, short int long int. These can be signed or unsigned here. Right? Okay. Next, size of data types. When come to size of data types here, yes, okay, there are two types of compilers in C language, Turbo C and ANSI C. Okay. Size of signed, unsigned same, only sign is difference here. Size of signed, unsigned both are same, only sign is difference here. Next, size of character floating point same for the both Turbo C and ANSI compiler. Two types of compiler, Turbo C and ANSI C. For both compilers, same size, no difference. Right? Okay. Next, size of the character is 1 byte for any compiler. Size of float is for 4 bytes for any compiler. Size of double is 8 bytes for any compiler here. Size of long double is 10 bytes for any compiler. Okay, no change, right? Okay. See, this is size. What we discussed here. Size. Okay. See, two types of compiler. Size of character is 1 byte for any compiler. Yes, float, double, long double. This is 4, 8, 10, right? So this is same for both compilers like ANSI C, Turbo C here. When come to integer here, yes, these are compiler dependent. This is Turbo C, 1 to 4 Turbo C here. Yes, in ANSI C it's a double here. Yes, in ANSI C, this is 2 bytes, this is 4 bytes, next this is 8 bytes, just double here. So this is for Turbo C, this is for Turbo C, this is for ANSI C. ANSI C, right? ANSI C means Linux based. It's Linux based, right? Okay. Yes. Same thing expand document here. See, size of integer is a compiler dependent. Okay. Yes, data type short int, long int. Okay. Yes, Turbo C 1 to 4, right? Yes, ANSI C maybe 32-bit or 64. Yes, 32-bit compile no one is in here nowadays. 64 bits. Turbo C 64 bits. ANSI C 64 bits. So 64 bits 1 to 4 here. This is what 248, right? Next, size of the pointer. Yes, this topic later we'll discuss. In pointers, I'll explain this. This is not a stage to discuss about pointer here, right? Okay. Next, size of signed, unsigned is same here. Difference is only sign. See, data volume minutes. What are we discuss? 1 byte, kilobyte, megabyte, gigabyte, terabyte, petabyte here. Yes, exabyte, zettabyte. Next, range of values. See here. Yes, character 1 byte, 0 to 255. It's a ASCII range. This is ASCII range. Short int 1 byte, minus 128 plus 127. Short int 1 byte. Yes, unsigned type. Unsigned 1 byte, 0 to 255 here. Yes, signed 2 bytes, maximal 32,767 here. Yes, unsigned int 2 bytes. 2 bytes maximal 65,535, right? Similarly, long int. Okay. Next, float double and long double like this. Right? Okay. Yes. If number is more than 6 is, then string is recommended. For example, yes, phone number, Aadhaar ID, and PAN number, right? Number more than 6 digits, then go for strings. Yes, difference between signed and unsigned here. Default is signed type. Yes, signed integer type. See, signed int a equal 10, for example here. See, yes, in signed type, last bit is reserved for the sign and remaining 7 bits for data. Right? Okay, 0 positive value, 1 for negative value here. Yes, number 10, its equivalent binary code is 1010. See this story is right. This is okay. Yes, in signed all bits for zeros, then it's a least value. All bits zeros, least value. Suppose all bits are ones, it's a maximal, right? Max value. Here maximal is 127, right? That's it here. So this is about data types. Yes, next about programming. Tomorrow we'll start programming here. How to write first program tomorrow we'll discuss. Yes, I think no doubts, right?
Yeah, I have one dot here.
Yeah, tell me.
In signed sort into, if you give one plus 128, it will throw error or it will give 0.
In signed 1 byte.
In signed 1 byte, if you give value 128 for int, it will throw error or it will give 0.
No error. Runtime fails. Runtime memory exception is. Okay.
Okay.
Compile time no error. Compiler never checking for value. Runtime system when try to store system ke shows error here. Runtime error. Runtime memory exception is this. Okay, right? It's a memory exception. Yes. Next, any doubts? Same
And
expression. Yes,
how
everything
to
is there.
Sir,
Yeah. Tell me.
and how to represent every
hello.
numbers in memory?
Sir, how they calculated minus 128 minimum value?
Yes, one person. He's two questions are asking. Yes, Sudarshan, what is your doubt?
How to represent negative numbers in memory?
Yeah, last bit is minus, right? Last bit is 1 means a negative value.
Okay, for 10 we dividing with 2. For minus 10, how will you do that?
Here, last, see, 10, in case of 10, this is 10, right? 10, 1, 0, 1, 0 like this. 0, 1, 1 like this, right? This the empty bits 0, this is 1. This is 1 means minus 10, that is. 1 storing here. Suppose
Internally, how it is calculating like
A
that?
equal to my, no, it's a sign type, right? In sign type, it won't touch this one here. In
Okay,
sign type,
automatically it will make it as a
is
1.
automatic taking as negative here. Okay, calculating up to this one here. Only 7 bits. It will consider only 7 bits. In sign type, considering only 7 bits. It won't consider 8 bits here. Only 7 bits. So last bit is 1. That automatic returns. Well, yes, the automatic returns minus negative value here. So this is calculating up to 7th bit only here. 7th bit 127. This is yes 1, right? Like this. I think clear, right? So you can last bit is sign. Last bit is sign. That case last bit is sign. That case a negative value. So calculating is in sign type only first is 7 bits. It won't consider last bit. Last bit is 1 bit is negative value. I think clear, right?
Yeah, yes,
Okay.
I get.
Yes. So this is about data types. Yes, yeah, that's all for today. It's already 7:35. I have next class. Yes. So tomorrow don't have the class. Next class on Monday. Only this Saturday canceling class. Next Saturday I'll be taking class. Okay. So next class is on Monday. Right? Okay. Yeah. Thank you guys.
Sir, one dot here, no character formats. It will not take plus or minus. It is unsigned only.
Characters. No. Characters who no plus no minus here. Rounded number. 0 to 2
Okay.
different
Yeah, that is
characters are unsigned. No
yes.
sign.
And uploading also unsigned.
Float is signed. See,
Hello.
character. See, once again, I'm repeating once again. See, character is always unsigned. That's clear, right?
Yes.
Character is always unsigned. No sign for the character. When come to
Okay.
floating point of this, always signed here. No unsigned type. Floating point is always signed. No unsigned.
Okay.
Yes,
Okay.
integer. Yes, integer case either signed or unsigned here.
Okay. Okay.
Integer.
I got.
I think you understand, right?
Yes.
Characters always unsigned. Floating point is always signed here. Yes, integer type is sometimes signed, sometimes unsigned here. Yes, unsigned integer, it's a pointer concept. In pointers we'll be discussing about unsigned, except pointers remaining all are signed type. So what are the variables we are declaring in programming here, that is signed variable. So not unsigned. Yes, every data is signed data. Only pointers are unsigned. Yes, in pointers we'll discuss that. Right? Okay. Yes, in pointers we'll discuss about unsigned here. Except pointers, remaining everything is signed type. Yes, in pointers I'll explain that. I think clear, right? Yes. Okay. That's all for today. Okay. Let us wind up. Yes. Thank you guys. See you on Monday. So next class will be on Monday. Okay. Yes. this guy is Shiva Sanam. Hello. Shiva Sanam. Are you able to listen me? Okay.